What's going on, guys? Welcome back. Today we are going to talk about the most recent room in TryHackMe. The room's name is Bugged, and the subject of this room is the Internet of Things. So we haven't done any video before about the Internet of Things and how to do penetration testing or security analysis of Internet of Things devices. So this is a chance to talk about this in this video by doing this room. So let's read the description and understand what this is about. John was working on his smart home appliances when he noticed weird traffic going across the network. Can you help him figure out what these weird network communications are? So typically we have an Internet of Things device set up at John's home. Now this Internet of Things device is communicating probably with John's smartphone or John's computer. So there's a client that's installed on John's smartphone or John's whatever desktop, and from that point he's monitoring the let me call it traffic or the metrics. Maybe he has installed some sort of temperature monitoring or maybe movement sensor. Whatever the sensor was, he is monitoring all of the metrics and the parameter values right from his desktop or from his smartphone. Now for that to happen, the Internet of Things device, i.e. the smart home appliance, needs to connect to the internet. So most probably it's using the home's or John's Wi-Fi or his home's Wi-Fi to connect to the internet in order to send and receive the metrics to John's smartphone or John's desktop or computer, whatever it was. Okay, so this means that if the smart home appliance is sending these parameters or metrics through the internet, it means it's running a server on its own. Most probably it means that the appliance is actually running So to understand what we need to do here, the first thing, so to understand what we need to do here or how to get started, first, this IP address so what does all that mean? It means that this IP address here, 10.10.26.153, belongs to the smart home appliance. And there must be an open port on that IP address. Okay, through that port there is a server running which sends and receives the data to John's smartphone or John's desktop. Okay, so that's the starting point. We have to find out what is that port that the smart home appliance is running on or the server is running on to send and receive the data. So if you do the nmap scan on this IP address, you will find out that the open port here is 1883 and it's TCP port, open port, and it's running Mosquito, and the version is 2014. As you can see, there is mqtt-subscribe. Now to find out what is that, you can use googling, and basically all boils down to something called the MT or MQTT protocol. This is the official protocol used by Internet of Things devices for the communication. It runs actually on all Internet of Things devices that send and receive data. It is lightweight, as you can see. We can read on the page all of the features, characteristics of that protocol, and most importantly to highlight is it's a machine-to-machine protocol, right? From Internet of Things device maybe to other Internet of Things device or maybe to another smartphone. Provides communication between devices. The other thing is that it runs on resources constrained networks, such as home network, for example. It's designed as simple and lightweight messaging protocol that uses publish subscribe. We can explain this. So if you scroll down, this is the architecture of the MQTT protocol and how it works. So basically, he's the publisher and he's the subscriber. The subscriber receives the data. The publisher sends the data. So if you are talking about the current scenario here in this room, the smart home appliances mentioned in the description are most probably the publisher. They sent the data about the metrics monitored, such as the temperature, such as the movement around the house. Maybe it was an infrared sensor somehow. So it sends these parameters and the values to the subscriber. The subscriber is actually the person or the end that receives the data. It can be a smartphone or it can be a computer. So here it can be John's smartphone or it can be John's computer receiving the data about the metrics from the Internet of Things device or a smart home appliance. Now all of that happens through something called the MQTT broker. Now MQTT broker is the entity that facilitates the process. So without the MQTT protocol or broker, the messages exchanged between the publisher and the subscriber, won't actually get exchanged. So it's the job of the MQTT broker to facilitate the exchange of the messages between the publisher and the subscriber. So when we call the subscriber and the publisher, we call them both the client, and we call the MQTT broker as the server. So without the server, the clients cannot communicate. Okay, so let's go back here. And one thing to explain before we move on to the practical challenge is to understand that the messages sent from publisher to subscriber, we call them, they contain topics. The topics are the actually parameters or the metrics we want to monitor. Okay, so the subscriber, whether it be smartphone or computer, subscribes to these topics and therefore receives the messages from the subscriber or from the publisher about these topics. So topics, again, they are the parameters or the metrics we monitor in the Internet of Things device. Okay, let's go back. And thus all of these lines now make sense. If you take a look at this one, this is a topic sent from the publisher to the subscriber. This is another topic sent from publisher to subscriber, and they're about, as you can see, lights, camera. We have this one, speaker. This one about the temperature. So this is the topic, and the rest are the, as you can see, the broker displaying the metrics about the communications. So what's actually the next thing to do? If you go back to the description of the challenge, it's required that we find out about the weird traffic going across the network. So if you go back to the diagram here, our network in this case consists of the smart home appliance, the smartphone or the computer that receives the data, and the MQTT broker that sends and receives or facilitates the send and receipt of the information. So that's our network. We want to find out the weird communication happening. It means that there are messages or maybe even topics exchanged, sent from the publisher to the subscriber that are yet to be discovered or yet to be unveiled. What's the content of these topics? So in order to unveil these messages or topics, we have to simulate somehow the publisher and the subscriber. We want to simulate the publisher and subscriber. It means at one time we will want to send information to the subscriber, and on the other hand, we can also open a new tab here and send information from the subscriber to the publisher requesting to subscribe to some topics, for example. So to do all of that, let's first get a list of all of the topics or the messages exchanged between the smart home appliance and the subscriber in our scenario. So to do that, we will need a broker. The broker in this case is already installed on this machine. Now if you go up, as you can see, the broker name is mosquito_sub. So here, let's make this bigger first. Zoom in. So mosquito_sub dash help. You can display now the help menu to be able to find out how to deal with this. So as you can see here, I want to use this client program to send and receive data to simulate the publisher and to simulate the subscriber. But the first thing, I will need a couple options to work with. The first thing here is the host, the MQTT host to connect to. Okay. Now this host is we have the IP address here, and we will also need the topic. So -t MQTT topic to subscribe to, maybe repeated multiple times. So through -t, right, we're going to send and receive the required data, or data that we will want to filter, or sorry, want to unveil or uncover. Okay, so first, as we agreed, let's first retrieve the list of all of the topics. Okay, so to do that, we can do mosquito -t. We can use the pound character to receive the information about all of the topics, and -h we define the host, and as you can see now, we are retrieving all of the topics exchanged between the publisher and the subscriber. We uncovered some of these in the in-map scan, as you can see, but of course there are a lot more that can be uncovered outside the scanning process. So if you go back here, take a look at this weird traffic going across the network. We just agreed that the traffic in our case is the messages exchanged. The messages contain the topics, which contain again the parameters to be monitored. So this is the list of topics, and as you can see, we have weird one, this one. So it's kind of base 64. So if you take this, we wanna decode this one with the help of CyberChef. So with CyberChef, we can from base 64 provide the output, and this is it. Take a look at this. We have an ID here, much similar to the other topics. So that's the formula. The topic follows this format. So first we have the ID of the topic, okay, whether it's in use or not, true for in use, false for not, the parameter or the metrics we want to monitor, temperature, and the value of the temperature and the time, toast time. And nearly all of these topics follow the same formula, as you can see here, the ID and the parameters and the whether there's movement. Of course, some parameters are actually different between topics due to the nature of the topics being monitored. And the list goes on, as you can see. Okay, so that's one topic. That's the ID, and we have registered commands. So that's the metric actually, or the parameter. Registered commands, and contain 3 commands: help, cmd, and sys. The pub topic, the publisher topic, and the subscriber topic. Okay, so here we have a topic that's being published, and we have a subscriber topic that's being actually received on the other end, meaning the smartphone maybe, or the computer. So here we got now the weird communication going over or across the network. What to do next? Okay, what to do next, we have to simulate the publisher and the subscriber. Meaning that if we simulate a publisher behavior by sending this topic, okay, and if we simulate the subscriber behavior by requesting to receive this topic, we will be able to uncover the weird communications across that's going across the network between the publisher and the subscriber. Okay, so let's stop this one and use again mosquito. In this case, instead of bound, we're going to replace it with the publisher. So now we are acting as the publisher. And we are sending this over on different tab. Here we can view, zoom in again. All right. Let's take this one. And from here, we can take the subscriber token. Right now we are simulating the subscriber. So here, instead of this one, we replace this with the subscriber topic. And right now we are simulating the communication between the subscriber and the publisher. We enter. Let's take a look now. Okay, so basically nothing happened. Okay, so basically the mistake we did here is, as you can see here we used mosquito subscriber, right, to subscribe to this topic. But here we have to use the mosquito publisher to publish this topic. Okay, so here we have to add a test message -m test. Let's see now. As you can see, we received a base64 value because now we subscribe to this topic. So let's now get this one and take a look at the encoding of this value. Invalid message format base64 ID, backdoor ID, CMD command, and argument. Alright, so it's here saying that this base64 format is invalid message. So in order to make it valid, we have to follow this format. So this is the essence of the weird communications going between the subscriber and the publisher. As you can see here, all we need to do is to add an ID here, okay, add a command and an argument to execute. Okay, so basically here, that's how we execute the system commands from the between publisher and subscriber. So let's take this one, starting from here. So instead of from base64, we're going to use to base64. Let's delete all of that. To base64, put this here, and now let's put in the commands. So let's use ls, okay, and the backdoor ID is the ID of the topic itself. So if you go back here, going up to the list of the topics we have uncovered, okay, that's the base64. Let's take it back, copy this back, and then going to cyber chef. So here, let's paste this one here, open a new tab, from base64. Okay, that's the ID mainly. We take this one and we put it here. So the command CMD and the argument. So if you remember, if you go back here, as you can see, registered commands are help, CMD, and sys. So here we're going to replace this ls with CMD, and the argument will be ls. Okay, so now we got the base64 of this one. So what are we going to do here? To execute this command ls, we're going to need to send this, okay, as a message from the publisher side. So let's go back, keep this running, okay, because you are subscribed to this topic, and to the new tab here, send a new message. Keep everything as is. Instead of test, we're going to send this base64 message. Let's see what we got here. Okay, we got another base64. Let's take it and decode it. So from base64, as you can see here, that's the response, the ID, right? And the responses, we got a flag. So we were able to list the files, as you can see on the current working directory, by sending the base64 message we uncovered from the publisher to the subscriber. So what's next? Next is to go back here, take this, delete this one from base64. Yeah, we have to go back to the original one, which was here, and craft a new command. So from base64, okay, let's take this one more time. To base64, the ID is here. Where was the ID? Yeah, this is the ID. So the command here will be again cmd. You cannot type, it's not the place to put the command here. It will be in the argument, because the allowed commands, as you saw earlier, are these only: cmd, help, and sys. We use cmd to indicate that we want to execute system commands. And here the argument will be cat flag text. Let's take this one and send it as a message. And we got this. Let's decode this value. Hopefully it will contain the flag. Now from base64, now, okay, let me, for cautionary purposes, I don't want this to go away, so I'm gonna open a new tab, paste this here, open a new tab, and put it here. And this is the flag. So that was it. Totally new learning experience. The challenge is cool. Maybe it can be a starting point if you want to learn how to do pen testing for Internet of Things devices. But the most basic thing to understand before jumping into all of that is the MQTT protocol and the architecture of the publisher and the subscriber relationship, and how it works, and what is the role of the MQTT broker. So without this software here that facilitates the communication, this one acts as the broker. As you can see, the subscriber to receive the message and the publisher to send the message. And here we specify the topic. In that case, or in today's video's case, it was the base64 encoded topics. We encoded them, decoded them, and we got the formula of the topic that has been exchanged between the subscriber and publisher. Following that formula, and given the fact that we know the allowed commands here, we were able to execute system commands on the Internet of Things device to retrieve whatever we want to retrieve. It was the flag. So that was it. I hope you liked it, and I will see you in the next video.